So the first problem that I'm going to do today is in section 3.2, and we're going to be looking at problem number 46. And that problem says that if we have 3 over the square root of 2, and we're going to be asked to rationalize the denominator. And when we're talking about rationalizing the denominator, we're talking about taking the radical out of the denominator. So when we say radical, we mean anything that has the radical sign. So part of our rules for simplifying radicals is that no radicals allowed in the denominator of simplified fractions. So this goes back to our rules of simplifying fractions. Fractions there. Can't talk and write at the same time. So our rules for simplified fractions say that we have to make sure that our index is more than our exponent inside the radical. So the index must be more than exponents inside your radical. And then another rule is that, or another rule for simplification is that no radicals are allowed in the denominator. So let's go ahead then and look at this fraction. And when I rationalize the denominator, I'm going to be multiplying by a radical that has the same index. So I'm going to put that both in the denominator and the numerator. And it has the same base in it. And then when I go to multiply, I want to make sure that when I'm multiplying, and right now I'm just concerned about the denominator. So I'm going to be multiplying 2 times 2. And remember that when you multiply and you have the same base, what do we do with our exponents? We add them. So the exponent on this particular 2 is 1. And right now the exponent on this 2 is also 1. But we could change it. Remember, we put this fraction in here, so we can change it to anything that we need to change it to make sure that we get rid of this denominator and that radical. Well, not the denominator, but the radical. Alrighty, well, let's suppose that we do have a 1 on each of these 2's. When I go to multiply, I'm going to have the same base, and then I'm going to add my exponents. When I add my exponents, I end up with 2 to the second. This is actually my desired radical. So I am looking for, or my goal, to have the index and the exponent be the same. So what I'm talking about is the exponent right here is 2. The index on my radical is understood to be 2 because it's a square root. So I have just achieved what I am trying to achieve. Why do I want that? Well, remember that when the index and the exponent are the same, what happens? Poof! The radical disappears, and you're just left over with your base. So maybe I should put that down here with the goal to have the index and the exponent be the same, and therefore poof! Radical disappears, and base is left over. So now I've been doing all this to the denominator. I should go back and do it to the numerator. So up on the numerator I have 3 times, in this case now it's going to be 2 to the 1. So whatever I put down here, I need to put in the top. I'm going to go ahead and multiply. The 3 stays on the outside, the 2's on the inside, and I'm just going to carry it on over. And when I get over here to the end, many students want to cancel these 2's. The top one is under the radical, the bottom one is not under the radical. You're not allowed to cancel them. So this is your answer, 3 square root of 2 over 2 for problem number 46.